Hello students. In the last example, we found out how to find the LCM of two numbers, 450 and 600. I found this slide online and I thought it was a great example of the differences between how to find an LCM and how to find the greatest common factor, which we'll be covering next. As you can see on this example, we're given three numbers, and we're trying to find the LCM and the greatest common factor of the numbers 8, 12, and 20. As we studied before, in the LCM, what you're going to do is you're going to find the prime factors of 8, 12, and 20 in this case, and then find those factors which are repeated the most. As you can see, the prime factors of 8 were 2 times 2 times 2. The prime factors of 12 were 2 times 2 times 3. The prime factors of 20 are 2 times 2 times 5. As you can see, for the LCM, they chose the factors that were repeated the most. And then they also chose those factors that were not repeated at all. The answer for the LCM and the number that all of those numbers have in common is the smallest of one of them was 120. We will see how to find the greatest common factor in the next slides. The greatest common factor is a number that is a factor of two or more numbers, and this is a common factor. For example, the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and of course 30. The factors of 1 and 5 are 1, 3, 5, 7, 15, 21, 35, and 1 of 5. If you're wondering how we found the factors, remember that we always use the tree or the T diagram. The greatest common factor, or GCF, is the largest common factor of the two or more numbers. The common factors of 30 and 1 of 5 are 1, 3, 5, and 15. Therefore, the greatest common factor of 30 and 1 of 5 is 15. You can see some examples that I found online of how to find the greatest common factor. You want to find the factors that are common to all three numbers. Let's go to the blackboard and do some examples. Here's our blackboard. We're going to find the greatest common factor, or GCF, of 90, 168, and 420. First, as always, we're going to do the trees. Follow with me. Let's see if you get the same result. Sometimes it's useful to get your calculator, just in case. We know that 90 is divisible by 2. That will give us 45. And we know that if we have 4 and 5, that's 9, and that's divisible by 3. That will give us 15. We know that 15 is divisible by 3 because if you add 1 and 5, that will give us 6. 15 divided by 3 is 5. And then we know that 5 only can divide in itself to get 1. The factors of prime factorization on the number 90 is 2 times 3 times 3 times 5. Now let's try 168. We know that 8 is an even number, so we know this is going to be divisible by 2. Now, I don't know exactly by memory how much it is, and I don't want to be wrong when I do this. So, in my calculator, I can put 168 and divide by 2. This gets me 84. 84 is still an even number. It can be divided by 2. That will give me 42. And as you can see, we can see it's an even number, so we can keep dividing by 2. In this case, it will be 21. 21 is divisible by 3, which gives us 7. 7 is a prime number, so it can only be divisible by itself and 1. So the prime factorization of the number 168 is 2 times 2 times 2 times 3 times 7. Now we're going to do the number 420. We divide by 2, and I think we get 210, but let's check. Yep, 210. If we divide by 2, we should get 105. Remember, you can do this faster by dividing by 5, but sooner or later you're going to run with the same factors. 2 is going to be just in a different place in the tree. I hope that answers some of you guys' questions. Now 105 can be divided by 3, giving us 35. How did I know that it can be divided by 3? Because 5 plus 1 is 6, and 6 is a multiple of 3. This will give us 35, and this number can only be divided by 5. And that gives us 7, which is a prime number, and it can only be divided by itself, or 1. The prime factorizations of the number 420 is 2 times 2 times 3 times 5 times 7. In the next step, after we find all the products, we're going to try to find the greatest common factor, and this time we're going to do it visually, so you know which groups you have to choose. Alright, let's continue with the step 2. We find all the prime factors, and I'm hoping you took notes. Now, I'm going to try to do this visually. We're going to put 90 here. We're going to represent the factors inside of the box. 168, and then 420. Remember, you can still do this with a tree or writing down, but I just want to show you this way so you can see it more clearly. The factors of 90 were 2, 3 times 3, 5, and that's it. Alright, in 168 we had 2 times 2 times 2, 3, and then 7. We didn't have any 5s in this case. And then 420, we have 2 times 2, 3, 5, and 7. Remember, for the greatest common multiple of factor, we're going to use the smallest of the numbers that repeat themselves. In this case, we get 2 and 3. As you can see, we got 5 and 7 that repeat itself for 90 and 420. But we don't have any 5s on 168, and we don't have any 7s on 90, so we can pick those. The greatest common factor for the numbers 90, 168, and 420, or the GCF, will be 6, because we multiply 2 times 3. I know that it can be confusing. The truth is that these problems come only with practice, so that way you don't get confused between least common multiple and greatest common factor. Let me know if you have any questions. I'm always here to help you, and you can send me your questions or discuss through email. Thank you, and I'll see you in the next lecture.